Hello friends, welcome to follow up. Let's have a look at problem 2689. Extract keys character from the rope tree. In this video, we are going to explain a solution based on recursion. So here we would also like to make some comments on the problem. So here we are given the root of a binary tree and an integer key. So besides the left and right child, so every node has other two properties or attributes. One is value and the other is length, right? There are two types of nodes in this tree. One is leaf and the other type is internal. So for leaf node, this node have no children, and also the length attribute is 0 and the value attribute is some non-empty string. And the internal nodes is of those nodes that has at least one child, and the length is greater than 0 and node value is an empty string. So here the tree described above is called a rope binary tree, and we define a function s. Basically you can understand s as a map from the node to a string value. So this function is defined recursively as the following. So if node is some leaf node, so we are going to set the value of this node after mapping by s to be the node value. Notice that for leaf node, the node value is not empty string, right? So this is a non-empty string. Otherwise, if node is some internal node, so in this case, actually, the node value is empty string. So you can concatenate this s node left and the s node right. So actually we can understand this map also as concatenate of s node left and s and the s node value, right? Because this is empty, we just add an empty thing or add s node right. So if we use the convention that s maps empty string to empty string, right? So here we want to return the keys character of the string as root, right? So here the note explains what's concatenation in the context of strings. So here we have two examples. So here we want to find the sixth character, right? So that's the concatenation result. So that is like this. So the sixth character will be B, right? So similarly, you can examine example 2. So example 3, so this is a very special because it just has one single root. It's also a leaf, so the value will be the string itself. So the eighth one will be this e, the last e, right? So the constraints are the following. First, the number of nodes in the tree is in the range given by a closed interval, so 1 up to 10 to the power 3. And node value contains only lowercase English letters, and the value length is bounded above by 50 and bounded below by 0. Similarly, the node length is bounded above by 10 to the power 4. So this is for leaf node. We have length equals 0 and the value is non-empty. And for internal node, we know the length is greater than 0 and node value is empty. So key is inbound, right? So with that said, basically we just need to follow the main statement to write the solution. So here first I'm going to define a function. Let's use this function s, right? So let me call this function getString, right? So this will be, you put a tree node. So here this getString basically is nothing but this s in the main statement. Then first I'm going to treat a very special case, that is a stop condition. So if not root, so we just need to return empty string, right? So then basically we want to do recursion. So actually we just need to make sure if it's a leaf node or not. Let's first treat the leaf node case, because now after we do this if check, root is not null. So one condition can be this: if say not root left and not root right. So basically it said that the root have no children, so it's a leaf. So for leaf, we just need to return the root, the corresponding value, right? Otherwise, we can call the getString function for left child and right child. So that is getString root left and getString root right, right? So then what we are going to do is to return left plus right. So here plus is nothing but a concatenation of strings. So with that done, basically we finish this function. Now we just need to call this function, right? getString and root. So this will give us the resulted string at root. And then for the return, we just need to return s. So because the s is 0 indexed, so we are going to return s key minus 1. So this is the one solution format. So before we make any comments, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here I want to make some comments. So here, this is the definition of leaf and internal. So if it's not leaf, it's internal, right? If it's not internal, it's a leaf node. So here in this if, this sort of long, I'm going to comment this out. And then we want to use an optional one. So another one, let's see. Because if the length is 0, it also means it's a leaf, right? So basically we want to check if this is 0. If it's 0, it's a leaf, we just need to check. So now let's test the code. Let's see. Here is root, right? Yeah, it passes all the cases. So this is one choice. Another choice is that we can also use this value, because the value is not empty, it will be a leaf. So if root value is not empty, so we can do this. So we can test the code directly. Yeah, it passes all the cases. So depending on your preference, you can use either of the three if conditions to do the check and to write the function s. So with that said, basically that's about it for this video. So I would say this problem, the statement is very long in a sense. However, the code is very simple and the logic is also very straightforward. So that's it for this video. Thank you.